In this next lesson, we'll be discussing radicals. Radicals are the inverse of exponents. So just like addition and subtraction are inverses, and multiplication and division are inverses and they undo each other, if you find yourself solving an equation where you need to undo an exponent, you're going to use what's called a radical. So specifically, we're going to be focusing on square roots, which are the inverse of squaring something or taking something to the second power. This is the notation for that, this little symbol here. You would read this as the square root of 4. And when you try to solve a problem like that, you'd be asking yourself, what number times itself equals 4? And you'd come up with 2, because 2 times 2 is 4. What number times itself equals 64? 8 times 8 equals 64. What number times itself equals 100? 10 times 10 equals 100. Now there are other radicals, not just square roots. For example, you could have a cubed root, and you would ask yourself, what number times itself 3 times equals 27? And you'd come up with 3 times 3 times 3 equals 27. Notice how we didn't put a little 2 in here for the index. It's sort of meant to be understood. If there's not a number there, we know it's a 2. It's similar to how we usually don't write 1 times x, or we don't write x to the first, or we don't write x over 1. Those are kind of like the understood 1. For radicals, it's a 2. If there's no number written as the index, we know it's a 2. Now sometimes the numbers that we try to take the square root of don't work out quite as nicely. Like I would say, what's the square root of 24? And you couldn't think of a nice integer that works out and gives you something times something equals 24. So we have several properties to help us deal with questions like that. The first one is the product property. The product property says that if you take the square root of a product, you can take that product, break it down into factors, and then take the square root of the individual factors, and you'd still get the same result. So this is a tool that we'll use to simplify these expressions. Now, in order for it to be simplified, we want the radicand, the number inside of the radical, we want that to be a number that has no perfect square factors other than 1. So for example, 8, the square root of 8, is not in simplest form because the square root of 8 has a perfect square factor, namely 4. I can rewrite 8 as 4 times 2, and 4 is a perfect square. If you're unfamiliar with the perfect squares, we'll make a little list of those here. Perfect squares are the numbers that you get if you take the natural numbers and you multiply them by themselves. So for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, then we've got 8 squared, and 9 squared, and 10 squared, and this list goes on forever, but those are our perfect squares.